Yeah, welcome. I want to talk about complex event flows in distributed systems. And basically what I want to do is I want to talk about common hypotheses I see out there. So we have quite a rise of the, let's say, kind of a hype, but also like in really adoption of event-driven systems out there. And commonly I see people talking about it like, okay, now we have these event-driven systems, and they are like the magic thing in order to decouple our systems, and everything we do should be event-driven. I want to look at that first. And then I want to look at the second thing, which normally comes up. If I do these event-driven things, I don't need orchestration at all. Orchestration is evil because it introduces coupling again, and we don't want to have that. And that's very often connected with the third thing, that this kind of like workflow technology is not required in that new world at all. It's kind of like painful tools from the past, so we don't want to have that in these new worlds. And that's basically my plan for today, to go over these things and comment on that. And obviously, it contains opinion, my personal opinion. Wes said that yesterday already. QCon definitely also likes to have opinionation. I mean, that's what you do. You talk about your own experiences. I just want to make it transparent, and Jonas already introduced me, so I'm co-founder of Camunda. We're an open source workflow automation vendor. I'm contributed to a couple of open source engines in the past, so what I basically do all my professional life is working with workflow engines. And that means I look through the lens of workflow automation onto a lot of problems, and that's probably good to know. But in that time, over the last 15 years, I saw like thousands of customers doing kinds of different workflows in different industries with different architectures, and that's what I try to bring together today. That's my plan. I love using examples. So the example I use today is motivated by Zalando. You probably know Zalando. They're active in the UK as well. They are sometimes like position themselves at the Amazon for shoes and clothes. They're a German startup. They're growing really quickly. And they also have, obviously, an order fulfillment process. I cannot show the Zalando order fulfillment stuff here on stage and in the public slide. So I do much simpler workflow here, and that's motivated by the Amazon Dash button. You probably know that. It recently got forbidden in Germany, but it's still, I think, available in the UK. So the idea is you have the Dash button, and you put it like next to the washing machine. If the washing powder is empty, you just press the button, and then one box of washing powder gets ordered at Amazon and shipped to you. A very easy order fulfillment thing. Okay, that's the example I use here. In the background, that's still an order fulfillment like workflow, but like in a way that you press the button and then you have to pay for it. That's normally done by the payment details you already stored in your account. Then it obviously has to be fetched from the warehouse and shipped to you, right? That's the workflow which should happen in the background. If you want to design such a system, nowadays you probably want to look into DDD, domain-driven design. That's something I can totally recommend. That's a really good book. And that talks about something called a bounded context. So you have to slice your domain into these kind of contexts where it makes sense to have like really one domain language and these kind of things. It could be that you end up with these 4 bounded contexts here. It could be different. I mean, that's like depends on a lot of factors. But for today, I want to make the example with these 4 domains. And if you go for microservices, normally that's a natural candidate to be microservices. So you have the checkout communicating with the button, you have the payment, like getting the money, you have inventory, like doing everything what's on stock and fetching it from stock, and you have shipment in order to get it to the customer. Okay, that makes normally quite a lot of sense. So I don't want to define microservices here. I just want to mention one thing which I think is important to keep in mind. I will come back to that later on. So my view on microservices, why are we doing microservices? We want to have autonomous teams caring about the separate microservices. So every microservice has an own team caring about it, its own like data set where the data is stored independently, so not a joint database, not a shared database. And we want to run on like different, whatever it is, virtual machine, like Kubernetes pods, whatever, it's separated. So everybody can run on its own, can deploy on its own. That's the basic idea, okay? That's just the like introductory stuff. So let's look at how you can build like a system out of that with event notifications. And let's do an example. It's not in the dash button, but you could imagine something like, if you press the button, it should like blink quickly green that we can ship within 24 hours. Could be a requirement you have to implement in such a scenario. And the naive approach of implementing that would be, I mean, the checkout service communicates with the button, so it has to know if it blinks or not, but it doesn't know it. I mean, it doesn't know about like what's in stock. So the naive approach would be like, hey, I ask the service which knows about, which is the inventory. So I could do something like a request and response, like an RPC style of thing, and ask the inventory, hey, do you have that item on stock? Can I ship that like in 24 hours? I get a response, and then I can blink or not. It's not necessarily like really RPC here. It doesn't have to be like HTTP or REST or something like that. It can be messaging. It can be a request message waiting for the response. I'm not talking about protocols here. But it means that I couple these together in a way that if the inventory is not available, I cannot make the button blink. I might add some latency because I have to ask over network. Maybe inventory has to do a couple of other things. So there are a couple of downsides of this approach. The most obvious is the temporal coupling. So if inventory is not available, checkout cannot do that, right? So the alternative would be to use like an event-driven approach where it's more like, hey, we have that inventory down there, and inventory sends out events whenever something happens, which is relevant for the information what's on stock. So for example, hey, there's new goods on stock, or something is just like moved away from stock. And you could send these events to a bus, like to the outer world. It's kind of a broadcast thing. And then the checkout service could say, hey, I'm interested in that. I read all these events. I build a local data of what's on stock or not. Only that limited amount of data which is interesting for me. It's kind of a cache. A lot of people think about that as a cache, which I think it's valid for that. But the important thing is now I don't have to ask inventory in order to make basically to say if it should blink or not, right? It has also disadvantages. I mean, it might be off by a couple of milliseconds, so that's about eventual consistency. It might not be the real amount on stock, but it has a couple of advantages to do this kind of thing. That's one way of thinking about event-driven. There's another example in this small like order fulfillment thing, which I also think it's quite a really good example of using event notifications. So you could say, if you have events flowing around in the systems which do probably saying something about, hey, there was an order placed, or hey, there was payment received, or hey, there was goods like shipped at the moment. You could build a notification service, some service which sends out emails or whatever it is, SMS, texts to customers, like completely on its own. So you don't have to think like on the left-hand services about when should I send an email? Did he give his GDPR compliant consent in order to send emails? You can like really centralize that in that one service. You have one team only caring about notifications. So that's a good way of thinking about that, because then you have like a clear responsibility what this service should do, and you really get it out of the other services. So that's a good part of event notifications. So yes, event can decrease coupling, and I think there are really good use cases for that. But as always, if you have that hammer, people start applying it for a lot of things. And what I saw over the last years, like emerging in a lot of situations, is that, I mean, if you have these services and you have to implement that workflow, like pay, fetch, and ship, what happens sometimes is that you can do that with event notifications as well. And it would look like, hey, checkout says, hey, there was like order placed, somebody pressed the button. And then probably you say, OK, payment is first. So payment listens to the order placed event, does something, whatever it has to do, and then like emits another event where it says, hey, the payment was received. And eventually knows, oh, if there was money received, I have to fetch the goods. And then it emits another event. And shipment says, hey, if there are goods fetched, I should ship them, and so on and so forth. So obviously, you can implement these, and that's what I call that complex event flow, because very often it's not just for services, it's much more. You can implement that flows by event notifications. The problem I see with this approach is that you're kind of losing the sight of what's going on. It's hard to understand how the workflow on the right-hand side is implemented there. You really have to look at the events during runtime, what's really going on. And that gives me, personally, it gives me like a weird feeling. I don't really feel comfortable with that. I discussed that very often over the last years. Very often I get the response, yeah, you're that workflow guy, you're that orchestration guy. I mean, your tool is not on the slide. There's no place for your tool on the slide, so obviously you don't like that. But that's not the real reason. Actually, whoever knows me personally knows that I would rather dump the product than the architecture if it doesn't fit. So I really have a bad feeling about that. The good thing is now it's 2019, so you find a lot of like blog posts or things out there which back up that bad feeling I have there as well. And the most prominent one is from Martin Fowler. He blogged 2017, beginning of 2017. He said, the danger is that it's very easy to make nicely decoupled systems. I mean, that's not yet the danger, but that's why we're doing it, without realizing that you're losing sight of a larger scale flow and thus set yourself up for trouble in future years. So that captures very good the feeling I had with these kind of architectures as well. So if it's just about losing sight, if it's just about not knowing what's going on, probably one approach of looking at that would be monitoring or tracing all these kind of tools. I just recently wrote an article, it was published last week on InfoQ about like monitoring workflows across these collaborating microservices. And I basically go through a couple of approaches you could take in order to regain sight into these kind of workflows. So one thing you could do is distributed tracing, or these kind of tracing tools, open tracing. There are a couple of them, like Zipkin or Jaeger, or if you're in AWS, X-Ray or whatever. There are a lot of these kind of tools which basically can give you some kind of, let's say, call stack throughout your distributed system, throughout different components, where you see you send the first request and you see how it rippled through the whole system. So that gives you an idea, but it has the downside of its being very technical. It's normally focusing on really very technical details, like what's the exact message, like method calls, services invoked, functions invoked. It's not like, it doesn't have a business perspective on that. It's much too fine-grained. Another problem is normally tracing does sampling. So they write like 10% probably of all the requests. So you don't get a complete picture of what's going on. Very often you only look at failure cases, not at the happy cases. So this is, I think, not the best way of approaching it. It's an important piece, but it's more focusing on technical things. So what most customers I know are doing, they're building some kind of, whatever you want to call it, probably data lake nowadays. So what they really do is they take Elastic, put it somewhere, get all the events, if they have an event bus, and store it. And then they try to make sense out of that in order to understand the flow that's going on. If they're good at that, you can even hook in own visualizations. So there are frameworks like bpmn.io, it's open source. You can just build it like a small HTML page in order to visualize events on a workflow model, like graphically. So there are ways of doing that. The downside, I think that's a very powerful approach. The downside of that is that you have to put some effort into that to make it happen. So it doesn't come for free. There's another range of tools which are normally called process mining, which I'm conceptually are really curious about. I like what they're doing. So they try to make sense out of events. So they try to gather what's the normal flow out of these different events and what are the workflows going on here. They try to make a discovery on that. The problem is most of these tools really focus on log file analysis. So if you're really in an event-driven system, probably using Kafka or whatever, you're not really into that world. So they are not, and also not very developer-friendly at the moment. So I hope this will evolve a bit more and give you some more insight. And there's the last approach. I want to talk about that later on, not now, which is called, or I call that process tracking. But I come back to that in a second. If you want to read about that, there's the InfoQ article. I summarized that there. But there's one problem that still remains. Now you have some insight, but what you still have is something like, I took that from a talk from Stefan Tilkov at the Micro Exchange last year in Berlin. He talked about microservice patterns and anti-patterns. The talk is on YouTube. It's linked there. Totally recommend to look through that. And he, at one slide, he said, OK, but this is getting emergent behavior, right? Because it emerges during runtime. You don't design it up front. It's emergent behavior. And I like, actually, the real slide where he has, how he also calls emergent behavior. And I think that's what a lot of people here know as well. It's kind of, for me personally, I know that's totally unfair comparison, but it often reminds me of database triggers. Like, hey, I write something in database, something happens, I have no idea what. So you have to be at least cautious about these, emerging behavior. I'm not saying it's a bad idea. I'm just saying there's a risk involved as well. And I can make another example which makes it very, very, let's say, transparent what I mean here. Let's assume you want to change that workflow which is going on here. So let's just assume you want to fetch the goods before you wait for the payment, which is actually not that unrealistic. I mean, we have same-day delivery nowadays. It's actually Amazon sometimes fetches goods from their stock before you checked out. That's an amazing thing, actually, because they can predict what you might order if you have recurring orders. And they already fetch it before you order it. And I heard they're pretty good at that. So it's not unrealistic to change orders here to get faster. Everything gets faster. If you want to do that, so like visually it would mean like these two, like changing the sequence of these two things. On the left-hand side, it means that I have to change a couple of event subscriptions. And I actually like this effect. Because what you can see is that you have to change 3 services down there. It's better than like REST calls. If you have a REST-based architecture, it means you have to change all 4 of them. But it's still 3 services, and I have to change them. And I have to coordinate the deployment because I probably have ongoing orders in my system. And they're flowing around somewhere. And I change that order. I have to make sure whenever they arrive in payment that they know if they already fetched the goods or not. Otherwise, it will not work. So I have a versioning problem. It's not totally trivial to solve that. And it probably also means that you have to redeploy at the same time, and you have to talk about that. You have to coordinate between the microservice teams. And that's actually exactly what we don't want to do with microservices. That's the slide. I learned that metaphor from Eric Evans, the guy who wrote the DDD book. And that's a 3-legged race. So it means like we bind teams together by their feet, right? If they coordinate, I bind them together. And what you can see is they run like slower as if they would run on their own. And the risk of falling down is much higher. And with microservices, we want to cut that tape, which tapes them together. But this is not happening here. We tape them together again because we have to coordinate there. So this is not really like in the sense of microservices from my perspective. I even use this picture a lot recently. So what I saw in a lot of talks whenever they talk about like event-driven systems and choreography, these kind of things, they use that metaphor. I never totally understood why, but it's kind of a dance where you don't have a central orchestra, like a conductor. But these professionals, they just dance because they know how to dance. And you can add another professional, and it will be a beautiful dance because he knows how to behave in that kind of dance. But if I look at what I see at the companies really adopting it, it's, from my perspective, a bit different. It's probably still dance, but it's hard to manage sometimes. It's hard to understand what's going on. It's probably still fun, but maybe also a bit painful. So I see a lot of risk there involved. We did a recent survey just to give you some numbers. It's probably not the most credible survey there, but the top one challenge people saw with microservices, the lack of visibility into end-to-end business processes, their workflows spanning multiple services. So that's one of the top challenges people we asked saw. Okay. So what you can do about that? So in this example, what I would see is you could extract, in this case, the end-to-end responsibility of fulfilling an order to an own microservice. That's actually, for me, in that example, it's totally natural to do that. I mean, if you look at companies like Zalando, that's their main purpose why they're there. They want to fulfill orders. It's kind of naive thinking that there will not be a microservice doing that, because there are a lot of people which care about SLAs, which care about is that efficient how we fulfill order, which care about is there any order stuck or taking too long or whatever. There are a lot of questions people ask about the orders. So it makes a lot of sense to have this as an own microservice in that example. And then you can change the picture of how the communication goes. You would say, probably that's still event-driven, somebody pushed the button. And then you have the order microservices which can listen to that. That's still an order, an event subscription. That doesn't change. But then you could change to using commands in order to basically command the payment service to do something for you. It's not event-driven. It's really commanding somebody, hey, I want you to collect payment for me. Right? And then probably that raises another event when it's done, like payment received, and then can go on. And that's an important concept. Actually, if you look at DDD, for example, domain events are there. Domain commands are not a concept there, and I think they should. For me, that's an important thing in order to get that going. And so on and so forth, probably then the order service commands the inventory and the shipment. And then you have a single point where you can control the sequence of things. And for me, that's not an evil thing. For me, every time I have two services communicating, you will have some kind of coupling. There's no way around that. It's some kind of coupling. And it either means that you're like coupling on the receiving side, because then you know which event you're listening to and which data will be in that part of that event. So you're coupling in the receiving side. Or you could say the order sends out a command. Then you're coupling on the sending side, because the sending side knows which command to send and which data to add there. And in the first case, the checkout has no idea who picks up the event. In the second part, the payment has no idea who commanded that, which is much more natural for me. And if you think of payment, why should it know about orders? It shouldn't. If you think that through and you're building something like Stripe collecting credit card charges for your customers, that would, if you're event-driven, like listening to order place, it would probably mean you're listening, like every time somebody uses your service, you have to redeploy. That's kind of a weird, like, thinking, I think. So for me, it's quite natural to have these kind of commands there. It's not. Also, a lot of people think when I talk about that, think, hey, but you're proposing doing some kind of REST-ish things there. We don't want to do REST. We want to do like asynchronous messaging. OK, it's not about the communication channel. You can send events over messages. You can send commands over messages. For me, that's totally fine. It's just like a different concept. And what I see a lot, actually, in real-life architectures, that people doing commands, but in disguise, because everything has to be an event. And then you have something like payment required event. That's a command. Let's do it for me. It's not a payment required event. That's kind of weird. But if that works for you, I'm happy to do that if you're aware that that's kind of a command thing. OK. So I think commands are an important concept to keep in mind. And I'm pretty much aligned with CQRS thinking there as well. So I think that's not too controversial now. If you're doing commanding, one thing, and for me, commands are orchestration, because I tell somebody to do something. That's orchestration. As soon as they say something about orchestration, it's normally, oh, no, we don't want to do orchestration. We're loosely coupled. And I think that comes from a thinking like back in the, let's say, old SOA days. Then we often have things like orchestration, which is thought in a way like this. So you have these services, and then you have like the ESB, the bus. And you do the orchestration in the middleware, in the infrastructure, in the bus, because there's where these kind of ESB and BPM tools, and there you did the orchestration. And that's, like in microservice thinking, that's a fundamentally wrong approach, because, I mean, then you have like a central tool somewhere. You have to redeploy probably services on the left-hand side, always together with the orchestration flow. That's a three-leg race again. So there are a lot of reasons why this doesn't work. But this is not what I had on the slide. What I had on the slide, yeah, and you probably also know this famous thing from Martin Fowler, where he said, no, we don't want to do ESBs. That are smart pipes. We want to do dumb pipes and smart endpoints. And that's very much agreed on nowadays. But that's exactly, I mean, what I do. What I did is I didn't say the orchestration should be part of the infrastructure. The orchestration should be like part of one of your microservices, right? It's still a microservice. You can still do it in whatever code you like. That doesn't matter. But as soon as you command somebody, for me, it's orchestration. And for me, that makes a lot of sense and totally fits into that picture. If you read further in the microservice journey, you probably come across the book from Sam Newman, the microservices book in O'Reilly. There, in some chapter, he writes, if you do orchestration, you have the risk that you end up with a few smart God services that tell anemic CRUD services what to do. That's a risk. So like if I visualize that like this, like the order sucks in all the logic, right? And all the other services are not doing anything anymore. Well, I understand why this is a risk, and you should definitely like watch out for like avoiding this. But it's not what happens like automatically if you do orchestration. I think that happens if you do like bad API design, right? Then you can get these God services. And I want to make an example of that as well in order to make the point. So let's assume like order and payment, you already know that, and we sent that command of, hey, payment, retrieve money for me, collect money. Payment doesn't do that on its own because it's probably credit card charge, so it has to like ask a credit card service in order to do it, probably something like a SaaS service somewhere, waits for the response, and then it tells back the order what happened, right? Relatively easy to understand. What could happen is that, I mean, it's like what I said earlier, you press that dash button, so it takes your credit card saved in your account. It might be expired, right? So the credit card might get rejected. What a lot of like services do and a lot of developers do in this kind of situation, they just pass on that problem to the order service. Like, hey, credit card was rejected. And now you start leaking domain concepts of payment into order. Because order shouldn't know about credit cards, right? It shouldn't. And especially if you get new requirements like, hey, he pressed that dash button, he wants to give us money, so let him do that. If the credit card expires, send him an email, try to update his credit card. That was what GitHub and other tools are doing. If they want to recharge the yearly fee and your credit card is expired, they send you an email, hey, you have 2 weeks, update your credit card, then we're good. Right? And if you want to do these kind of things and you have this architecture, normally you start doing that in the order, probably because you have some kind of like orchestration tooling or workflows there. But that's okay, then you get a God service. But that's a bad API of the payment. What you should do instead is ask yourself, who is responsible of that problem? And that, in this case, is clearly the payment service. This handles credit cards. So I would do some kind of like architecture design where you say the payment service handles that and sends out like a response ultimately like payment received or failed. Nothing about credit cards, nothing, right? Either received or failed. But if we have these requirements about like handling 2 weeks or whatever, it normally means that this service has to be able to be long running, what I call long running. Because now you have to wait for 2 weeks, for example, in order to get it going. But this gives you a much cleaner API, and this avoids these kind of God services quite a bit. Okay? The problem I see with that, or the problem I see teams struggling with it, as soon as I say that, they say, yeah, but I mean, payment should be, stateless service was a good way, I mean, that was a good place to be, that was fun to code. But I mean, if you want to have long running, I need state. That's kind of ugly, I don't want to do that. I mean, if you're looking at state handling, it's 2019. There are ways of handling state, so the most naive thing is, I always call that like persistent thing, because it could be like manifold things. It could be like an entity, a database table, it could be persistent actor, it could be a document, whatever you like. So there are ways of persisting things. The problem is that this very often involves some additional things you have to do, and projects are really quickly like understanding that because they have to do, for example, some scheduling because you have to recheck if the 2 weeks already expired. You have to do versioning, what I mentioned earlier. Something is always going on, so you have to think about that. You have to operate that probably at scale. You want to have an operation tooling where you look into kind of problems. So there is a lot of things you probably get subsequently. So that's, from my perspective, also not the best way of doing it. There are these other types of tools which are either state machines or nowadays most often called workflow engines. And as soon as I normally propose that in projects, people are kind of, no, workflow engines that's crap, that's from the past, they're like really complex, they're these like 3-letter acronym vendors, big boxes, hard to understand, very proprietary. We don't want to do that. And that's not true anymore, and that's, for me, also an important message. So yeah, there are these kind of tools, very often marketed in a way where I say, hey, low code, we don't need all of you, we don't need developers in order to do the workflows. And that's, I mean, that's understandably crap. That doesn't work. To my experience, that doesn't work at all, probably except very simple workflows. I always call that death by properties panel because you have to click through a lot of property panels in order to do that. You cannot just copy and paste something from GitHub, but you have to watch a 10 minutes YouTube video in order to do that. That's crappy, so don't do that. Definitely not. But there are like different tools emerging, and actually a lot of them. So if you look at the cloud space, there's something like AWS, for example, step functions, Azure, durable functions, Google, Cloud Composer. In the CNCF, the Cloud Native Computing Foundation, it's an own workflow subgroup. So there's a lot of things going on about workflow. If you look at the Silicon Valley stacks, everybody built something there. So Uber Cadence, Netflix Conductor, Airbnb did Apache Airflow. So all of these kind of tools are emerging at the moment. If you look at the open source space, there are quite a lot of what I would call a lightweight workflow engines out there, which you can use, which you can easily leverage. Very often, I mean, most of the tools, except AWS here, are open source, so you can easily get started with that. What do I mean by lightweight? I don't want to go into any details. If you want to see some real code or run some real code, approach me later on. So I have my laptop with me. I'm happy to do whatever you want to see. For today, just to give you an idea, and I use Java here, you could use any language. But what you can do there, for example, you can build a workflow engine like in one line of code with a default configuration. You can define like a workflow in code if you prefer. What happens in the background, it's generated like a real graphical model automatically. You could also model graphically if you prefer, but I often have the impression that developers like the code first because they understand what's hidden in there. And when they see graphical models, more like, oh, there's some magic behind. I'm a bit afraid of that, don't you? But you can start with a DSL, and then you could attach, and that's BPMN, by the way. It's an ISO standard. A lot of these tools are implementing it. I totally love the language, so I can recommend at least to look at it. The adoption worldwide is quite good. And then you can attach code. Like, there's just, in this case, Java code, which is executed when the workflow runs through a certain step. And then I can start instances of that. And this slide, this code, you can copy and paste it in your Eclipse. If you're in Java, you can directly run it. So that's it, right? Now you have a state machine. Now you can do these kind of long-running things in a service. You can have something like charging the credit card. If that doesn't work, I probably send out some information to the customer, and then I wait for him to respond. And now I have the notion of time. This is persistent. I can wait for 7 days. I can do something else. Okay, it's very easy to implement these kind of things. Now we're in distributed systems nowadays. And actually, I'm quite happy actually to be on Jonas' track today because I stole that metaphor from you. I learned that from you the first time. That's a metaphor for distributed systems. So you have these different components out there, like which might be the small hut there. That might be one Java program. You have asset transactions there. You have threading under control. You're on one environment. You pretty much know what's going on there. But when you open the door, you face that like rough ocean, and that's the network. And there will be like incredibly bad things happening with the network. Peter Deutsch, Fallacies of Distributed Computing. The first fallacy is the network is reliable. It's obviously not. And because of this, we also face a lot of new problems we have. Just making an easy example here, if I do that payment and credit card thing, and let's assume I call a REST API here, what can always happen is that this is not available. It's a network. It's probably really the internet. So it might not be there. It might be a network hiccup. It might be a downtime, whatever. You should plan for this. And that's the same reasoning I did a minute ago here, because what you can do naively is the first like reflex of most developers like, oh, there's a network exception. I just like throw that to my client. And then you throw it to the order, and order should handle that. And order grows bigger and gets a God service. That's a bad idea. I mean, that's clearly about handling the credit card communication. It should be part of the payment. But in order to do that, it has to be long-running, probably. Especially if you want to have like really surviving like outages or downtimes here, because you can retry for minutes or probably even hours. It's an order fulfillment. It doesn't have to be done in microseconds. You have minutes or probably even hours to solve this kind of thing. Okay, so that's also long-running. You can make the same case with messaging, by the way. If you send out a message and never get a response, or probably get a late response, you have to care about that. You have to persist it. You have to wait for it. Okay, and that's relatively easy to do in this kind of tool. So this is all like, these are all examples of long-running. And there's even one, and that's my favorite example, actually, because a lot of people are not thinking about that. Which is surprising. So if you look at distributed systems, there's even one characteristic which is even worse. If you have, let's assume you have a REST call, and you do that REST call, you get a network exception. You have no idea what just happened. It could be that the network was just broken while you tried to reach the service provider. You never reached it. It was broken before. Or you probably reached the service provider, it started to do something for you, and it exploded. Did it like commit the transaction or not? You have no idea. Did it everything correctly and the response got lost? Could happen as well. So whenever you do that call, you get a network exception, or you send out a message, never get a response. You have no idea what happened. You could have done something or not. And that's something you have to think about, especially if you think about payments. You have to think about it. It could be something like, hey, I tried to charge the credit card. I even did retries for an hour, but I give up. And then I raise a payment failed event. I say, order, we cannot do that. But then I have to think about, for example, like a cancellation or refund or whatever the strategy is, but I have to think about it. And again, it has to be kind of like persistent, because if the service was not like really reliable when I try to call it the first time, chances are low that it's responsible when I do the cancellation. So this is, again, like long running. And then I think you get a much better and much cleaner API for the payment service. And that definitely avoids these kind of God servers, right? So that's, for me, an important kind of thinking. And what's connected to that, very often, that's also an important thought. So if I have this kind of workflow now as part of the payment service, right? It's an implementation detail of the payment service. It's just its internal logic. You might leverage some tool like a workflow engine in order to make that easier to implement, but you probably decide not to. You can store it in the database, or use persistent actors, or Saga implementations from vendors, or whatever. So you can do that as however you want. It's an implementation details. You don't see it from the outside. You don't see it by the API. And if you have other services also having this kind of logic, like, for example, the order fulfillment, which is, let's say, it's a coincidence that this is the end-to-end capability that also has a workflow. But it's a different workflow. It has no details about how I really do the payment. Just say, hey, I commanded payment, and now I waited for it to finish, right? Not much more. So you really separate these kind of things. So know what I call a BPMN monolith. I blocked about that, because that's what most people have in mind when I say something like workflow. Oh no, you want to do this kind of like huge thing which cares about everything, where it says, hey, if the charting doesn't go through, I ask the customer to update. A lot of things where you, in one workflow model, you mix all the like different bounded contexts. And obviously that's a bad idea. I mean, then you end up with a three-legged race again. You have one model where you don't have one clear owner. That doesn't make sense. So you have to have models which have one clear owner rooted in one microservice if you do this kind of like architecture. If you do a monolith, that might be good, by the way. So we start to see a trend back towards like appreciating monolith. So if you're doing that, you're definitely fine with that. So there's no problem in doing that. But if you do microservice, that's wrong. Right? That's an important thing here. One last thought on that. I had a talk yesterday on that. I called it lost in transactions. So what we see is we have a lot of like problems nowadays because we don't have these asset transactions anymore. If we have two components which are like communicating remotely, a distributed systems, we cannot simply use a transaction manager in order to commit or roll back. If you don't believe me, there's the paper to read in order to understand why. It's a really good paper. I'm a big Pat Hellen fan. And there are basically two reasons. The first is it doesn't scale. So if you have a bigger system, it doesn't scale because these kind of transaction managers are kind of a bottleneck then. And the second, it's too complex to understand. Developers don't understand it. Operations don't understand it. So you will never really master it in production anyway. So don't use these kind of distributed transactions. So he puts it in Cron's up, don't use distributed transactions. But we still have that requirement of doing like things where we say, hey, this should be all or nothing. This is a lot about where the mindset now shifts toward eventual consistency, right? And one way, I'm just like scratching the surface pace here, but one way of implementing it is also known as the Saga Pattern. So what you could do is, like, if you have extended payment a bit and say, hey, the first thing is I look at the customer account if he has credit, like a voucher or something on his account. If yes, I deduct it from there. And only if that's not sufficient, then I charge the credit card. Okay, but these are two different microservices I use here, or two different services. So if this goes wrong, I cannot roll back. I already did that thing here. So what I do instead is I do compensating logic, an undo. It's kind of a business rollback. And therefore, I have to define, and BPMN, by the way, can do that, where I say, hey, if this activity was successfully executed or executed in the past, please call this undo method. And workflow engines which understand BPMN can do that like out of the box. And that's also quite powerful. And I'm not sure if it's like fair to give homework at QCon, but I thought it's a good idea to start that. Try to do that with a pure event-driven approach with the services I sketched. I would be totally interested in. I did that exercise once, but it's really hard because that's kind of a complex logic, and it's really hard to do that. But if you send me a good example, I ruffle something, whatever. I make something up. No worries. Send me an email. For me, that's also very often, I started with monitoring and managing workflows, like getting insights into that. For me, it's about, I call that BizDevOps, and that's kind of started to be a thing as well. So you find BizDevOps in the web there as well. So what I talked about so far is a lot about, yeah, of course, I have these like workflow engine as a state machine, as a help for the developer to do something. And for me, that's a lot about living documentation. Then North can talk about that for ages as well, all these kind of things. So yeah, that's true. But that's one part of the story. The other part is that, okay, these are probably test cases, living documentation, so it's really executed. It's really code, these graphical models. And that's what a lot of people really miss in these kind of like emerging behavior thing, okay? This is not a picture in PowerPoint, it's code. But it's also about operations, and that for me is one of the important things. If there's something failed, like during runtime, like whatever, some service call is faulty, some bug, whatever, you have a clear understanding. You have some, I mean, the tools might look different or depending on the product you use, but all the products have something like this, where you can look into that, see, hey, there are failed instances. There is a problem. It might not only be 317, it could be like 200,000 probably. You look into that, you can investigate the problem, you can probably restart from there, you can understand it, and that even probably without involving like a core developer, right? That's an important thing, and you get a lot of statistical data and a lot of insight of what's going on. And that without, I mean, you can combine that, I come back to that, but for me, that's an important point. You have to balance that. So you have parts of the system where you want to have this like orchestration in the services, and you want to have parts of the system which really were choreographed by pure event notifications. Okay, so that's about BizDevOps. Coming back to, I had that at the very beginning, coming back to that monitoring and managing article, there's one last thought in there, and I skipped that at the very beginning, which is, I call that tracking. And that's actually an interesting approach. We did that at a couple of customers recently. So if you assume you have kind of an event-driven system, let's say you have some kind of event bus, for example, like Kafka or RabbitMQ or whatever it is, and you have these services like sending all the events. What you could do as a first step, you could attach something like, for example, a workflow engine in order to have a tracking workflow. So this doesn't control anything, it doesn't steer anything, it just listens. But whenever you have some order-placed event, you start an instance, and then you wait for the other events to happen. This already gives you an idea of if the system really behaves like you modeled it, first of all. You get all the tooling from these workflow vendors, where you can see something like statistics, operational, this cockpit thing I just showed. So you get already a lot of support for managing the SLAs, so that's a good start. And what you can do easily, you can like start on a journey towards probably using more orchestration. And that's what customers currently doing that started with this event-driven, like pure choreographed approach. They now move towards more orchestration in order, for example, just to add, like these are so-called timers in BPMN, so they can like look at the SLA and say, hey, this takes too long, I do something else, and whatever. And now this like tracking approach starts to get active, starts to use a bit of orchestration there, and then you can like do that, like extend that step by step. There's a good case study. If you fancy that, there's a YouTube link. It's a 30 minutes video where Vodafone basically talked about what they did. And they did more or less the same thing. They had a system which was completely like connected under the hood, which was hard to manage. And they started with a pure tracking workflow in order to see what's going on. And then they migrated, like step by step, to an orchestration flow for the certain extent and removed the links under the cover. And that way they got into kind of an orchestration approach. So that's a good source to also learn about that. Good. I love to actually to pull up a couple of quotes because that's what I see out there. 24 Hour Fitness, the biggest fitness company in the US, they did the same thing, and they said more or less, they started with a pure like messaging approach. They said, before mapping processes explicitly, we had no idea what's going on. And that's a common pattern. You see that again and again. And I have that, for example, from a good quote. There's a link from Josh Wolf. He wrote a Medium post, and he said, when they introduced some kind of workflow into the core issue, that addressed the core issue in a distributed system. Where is the source of truth for the coordination of these services? And the system they were replacing uses a complex peer-to-peer choreography that requires reasoning across multiple code bases to understand. That's a problem which you should solve there. OK. So I think workflow engines are an important piece of the puzzle. Look for lightweight solutions. Don't use the old school, big vendor stuff there. That's basically, by the way, to make the go back to the beginning, exactly what Zalando does. So they have kind of a Kafka derivative underneath, and they're using these kind of workflows on a Camunda engine on top of that in order to steer this kind of order fulfillment. OK. If you want to see more code, and I'm actually a code guy, so I hate only doing slides today, but you have the full example on GitHub in code. You can run it directly. You can approach me later on. I can show you what that means, really in code, in order to do. So if you look at my GitHub account, you can find that. It basically has all the services I sketched on the slides. It uses Kafka underneath, but it's basically, in the Spring example, it's Spring Cloud. So it could be Rabbit, it could be anything. So you can easily exchange various things and really look at what that means in order to get going. So to wrap it up, so events decrease coupling, yes, sometimes. There are good use cases for event-driven cases. So I think that's definitely something you should have in your toolbox. But I would avoid these complex peer-to-peer event chains because they are hard to understand, emerging behavior, hard to change. Okay, so that's kind of a risk you have there. You should be totally aware of that. Orchestration needs to be avoided only sometimes. I mean, that's the same thing from another perspective. Yeah, there are use cases where you want to be event-driven or choreographed, and you definitely don't want to use an ESB if you're doing microservices on a big scale. Smart endpoint dump pipes are a good idea, but you have to balance orchestration and choreography. Orchestration starts with the commanding of others from within the microservice, and that makes a lot of sense, actually. And then if you have long-running requirements, use tools for that, like a workflow engine. And I try to make the case that if you're able to make services long-running, you get a better API out of that. You can have the ownership better distributed, the responsibilities better distributed. So I think that's important to have something in your toolbox for that. That's all I have. Thank you very much.